So yesterday was expanding. Today we're going to reverse it. We're going to do the factorising. Factorise means that we want to put things into brackets, and there are a bunch of different types that you need to be familiar with listed off down here. So first type is just taking out a common factor. That's the very first one you learn about probably in year 7. Then there's difference of two squares. We expanded difference of two squares yesterday. We're going to factorise them back up today. Grouping in pairs, which you'll see has 4 terms. They're 4-term ones, and you do them in pairs. And then the last 2 types here we're not going to be looking at today, but we'll be doing them in upcoming lessons, is the trinomials. So you have the monic trinomials. Do you remember what monic means? It means 1. So it means the coefficient of the x squared is a 1. Whereas the non-monic quadratics or trinomials are the ones that have a number in front of your x squared. Okay, so but those ones will be coming up, not today. We're sticking with the first 3 types today. Okay, so example number 1, factorise each of these by taking out a common factor. That was the first dot point, taking out a common factor. So 5m plus 20, the number that you can take out of both of those terms is a 5. So you put that out the front. There's no common letters, so I'm going to open my bracket. Then you have to divide each term by the 5. So 5m divided by 5 makes m. And then 20 divided by 5 makes a positive 4. Okay, that's it. Part B, minus 4d minus 10. The common factor, if there's a minus in both of them, the minus needs to be a common factor as well. The 4 and the 10, the common factor would be a 2, and there's no common letter. So minus 2d, that's going to be my common factor at the front. Now dividing each term. Minus 4d divided by minus 2. The minus divided by minus will make a plus. 4 divided by 2 makes 2, and the d. Then minus 10 divided by minus 2, minus divided by minus makes a plus again, and 10 divided by 2 is 5. Okay, that's it. Part C, 30m squared plus 20m. Looking at the numbers, the highest factor I can take out is a 10. And there is also a common factor of m in both of those terms. So I can finally bring a letter out as well. Then open the brackets and divide. 30 divided by 10 is 3. M squared divided by m. I've taken one of the m's out the front, but there'll still be one more left in the bracket. Then 20 divided by 10 is 2. And I've taken that one m out the front, so that is it. Close bracket. Am I going too fast? I'm assuming that this is all very familiar. All right, so one more. This already looks partially factorized. Don't expand it. Okay, the whole goal is here that we do want it completely factorized. You can see that the bracket, the x plus 2 and the x plus 2, the brackets are actually the same. It is the bracket that is a common factor. So I'm going to take that whole bracket out the front, x plus 2. Then I'm going to open a second bracket to put the remaining terms in after I've done my dividing. So this first term, if I divide out that x plus 2 from it, the 2 at the front is going to be what's left. Then plus the second term, I've divided this x plus 2, so I'm going to have the 3x. So it's the things that are in front of both of those brackets that are going to collect up in the second bracket together. And that's kind of leading into factorising in pairs. We'll be doing that some more. Okay, so that's common factor. Question 2 says factorise using a difference of 2 squares. So we're now moving on to the next type. You should be able to look at the question and identify that this is a difference of 2 squares, and you will see that these always have 2 terms. All of them, they've all got 2 terms. I mean, I know that one's a bit complicated, but it is still 2 terms. And normally, but not always, you can square root both of the things that are there, and there'll always be a minus sign in between. Okay, difference means subtract. That's why it's called a difference of 2 squares. Difference of 2 things that are squared, right? So these always factorise into 2 brackets. To find out what goes in the brackets, we square root the first term. The square root of a squared is a, and it will be the first thing in each bracket, A and A. Then we square root the second term. The square root of 16 is 4, so that will be the second thing in each bracket, and then one of the brackets will have a plus and one of them will have a minus. It doesn't matter which symbol you put first, as long as there's one plus and one minus. All right, that's it. That's difference of 2 squares. Let's do it again. So we can see 2 squared things subtracted, so we know this is going to be 2 brackets like this. We're going to square root the 9m squared. Square root of 9m squared is 3m. Very good. That goes at the beginning of both brackets. Then square root the 4n squared is 2n. Good job, Maya. 2n and 2n, and then I just have to put a plus in the middle of one of them and a minus in the other. Okay, part C. It is still a difference of 2 squares, just a little bit not quite as nice because I can't square root 8 very nicely. But we can still stick to our method. It's just going to involve some surds. All right, so 2 brackets, square root of x squared is x, so x and x. Square root of 8, as I said, not very nice, but I can write it in surd form. Square root of 8 and square root of 8. Don't go to decimals. Okay, one's going to be a plus and one's going to be a minus. Now that is an answer. It's not the best answer because we're pros at surds and we know that surds should be simplified. Square root of 8, if I just take that over here on the side for a second, square root of 8 can be simplified. Think of your perfect square numbers. It can be divided by 4. It is square root of 4 times square root of 2, and the square root of 4 is 2, so it's 2 root 2. So instead of writing it as x plus root 8, I can write that as x plus 2 root 2 and x minus 2 root 2 to ensure that those surds are simplified. Okay, part D. This is still difference of 2 squares. I have got a bracket squared minus another number that's not going to square it very nicely, but it'll still work. So if we stick to our process, good morning, 2 brackets, the square root of this whole first term is going to be x minus 3. X minus 3 out the front of both brackets. Then I'm going to square root the 7, which is not very nice. I have to leave in surd form. Square root of 7 and square root of 7. Then in between, I'm going to have to put a plus in there and a minus in there. That's actually it, because I can't simplify square root of 7. I can't collect the square root of 7 with the 3, even though they're both numbers. They just don't add because they're not like terms. So that's actually as good as we can do for factorising for now. Sometimes you'll find that once you do that, there are things in these brackets that can go together. All right, that is difference of 2 squares. Question 3. Our third type for the day is factorising by grouping in pairs. You'll identify this when you see 4 terms. Okay, all of them. They all have 4 terms. And what you do is in the name. We're going to take them in pairs, 2 at a time, and we're going to find a factor of each pair. Normally you take the first 2 terms together and the third and fourth term together. So that's what I'm going to do for this first one. So the first 2 terms, just looking at the mn and the 3m, there's a common factor of m. So let's bring the m out the front, open bracket, and that would leave an n plus 3 inside, just for the first 2 terms. Now I'm going to look at the third and the fourth term. What can I take out of both of them? 3. A positive 3, so plus 3, open bracket, and put the leftovers inside. So that's going to be an n plus 3 inside of that. Now, it should always work out when you're doing this type of question that these brackets will be the same. Okay, if not, you may have done something wrong. They should always work out to be the same. So the n plus 3, this is like one of the ones we did in the common factor at the top. the n plus 3 is a common factor that comes out the front. Then we open a second bracket, and the m and the plus 3 from the front of each bracket here comes into the other bracket. And again, it doesn't matter if you put that bracket first or these two brackets, they can be switched around. It is the same thing. But that is factorising in pairs. Okay? Let's try it again. Part B. Factorising in pairs, we're going to take the first two and then the third and fourth. Okay, looking at the first two, what factor can I bring out? A q, good. Q, open bracket, leaves 10p minus 1. The third and fourth term, knowing that I have to make these brackets the same, what do I need to bring out of those? I need to bring out a 2, but not just a 2, because that would give me negative 10p. I need to bring out the minus sign as well. Even though there's not a minus in there, I need this term to be positive because that needs to be positive, right? So I'm going to bring out a negative 2 as my factor, so that then minus 20 divided by minus 2 makes a positive 10p. 2 divided by minus 2 makes a negative 1, and now I've managed to get my brackets the same. Okay, once the brackets are the same, the 10p take away 1 is the common factor, and the q take away 2 goes into a second bracket. One more of these, part C. When I look at these ones, as I said, we normally take the first two and then the third and fourth together, but unfortunately, there is no common factor with the first two terms. So occasionally you might need to take, say, the first and the third together. What would the common factor of the first and the third one be? An A and an 2. So there's 2 and A bracket. That would leave an x and a minus 9. Okay? That then means I need to take the, yeah?
Can you also do the first and the last one?
Yep, you could have. Yes, you could have. So often there's different pairs and you will end up with the same answer. Now if I look at the second and the fourth one, there's actually no factor to take out there, but I've already got a positive x and a negative 9. I'm just going to put them in the other order because then you can see that the bracket is actually the same. Then the x take away 9 is the common factor out the front, and the 2a, the number in front of here would be a 1, so I need a plus 1 for that next bracket. Okay, so we need to work on 8b.